let's talk about what scientific notation is. Okay. And it's a topic that's used obviously a lot in science classes, and it's a math topic. So if you were looking at something like how far away is the sun, and this is a really big number, right? 149 billion. Well, we could write that in scientific notation and it might look a little bit easier. So basically, what you do when you go for scientific notation is you're going to think that where is my decimal? So let me just move that blue line out of the way. My decimal right now is here. And what I'm going to do, when you write things in scientific notation, you write them in the format that it starts with a single integer, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Not a 0, not a 10, a single integer. And so I would write that as 1.4934. Okay, so basically I've taken care of these digits right there. But then the question is how do I convert that? Because that's not the same number. 1.49 is not the same. Like if this was money, this is like $1.50. This is like over $1 billion. Like it's not the same number. So what we need to do is we need to move that decimal place. And it's real simple. All you do is you figure out how many places do I move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to get it where I want. Okay? So this number, if you were to multiply it by 11 tens, you would get $1.49 billion or 1.49 billion meters in this example. Okay? So when you have a really big number, all you have to do is figure out how many times do I multiply it by 10. So, let's just think about this for a second. 1.4934 times 10 equals 14.934. And if I took that number and I multiplied it by 10 again, I would get 149.34. Every time I multiply by 10, it just moves that decimal place one place further to the right. Okay? So here's another example you might see in a chemistry 11 class. There's this number called Avogadro's number. And this gets painful putting this into the calculator every time. And the chemistry students can tell you that it's not much fun. So here's my decimal. And I'm going to move it, 1, 2, 3. And you'll notice that the way I've written my numbers, I've grouped them in groups of 3. And this is the way we do this in Canada, is we group them in 3. The Americans do it differently with commas. We don't do that in Canada here. Okay? But I'm going to group it 3. Look, I'm going to just go, okay, well, there's 3, and there's another 3, and there's another 3, and there's another 3, and another 3. Okay? So let's see, 1, 2, 3, 4, 5, 6, 7. That's 21 and 22. 23 places. So if I had to write Avogadro's number in scientific notation, I would simply put it as 6.02, and then I move the decimal 23 places to get it there. 6.02 times 10 to the 23rd, Avogadro's number. Okay, so here's one more example. I've got 245 million. I'm going to write this as 2.45, and I'm going to multiply it by a bunch of tens. Let's see, 3, 6, 7, 8. That's nice and easy, scientific notation. Can we do it with small numbers? Well, we sure can. So here we are. We have 0.0000078 in scientific notation. Well, I want you to think about this for a second before we solve that. Okay, well, I'll start to solve it. It's 7.8 times 10 to the something. Okay, so what is 78 divided by 10? Well, that's 7.8. Okay, when you divide by 10, you're just moving the decimal over. So what's 78 divided by 100? Well, that's 0.78. And what's 78 divided by 1,000? And you can double check this on your calculator if you'd like, but you shouldn't need to. Okay, so every time I get this, I'm just moving the decimal one further place. And this time we're going in the opposite direction. So we're going in the opposite direction. Here's my decimal. I'm going to go 1, 2, 3, 4, 5, 6, 7 places to get where I want it. So this would have an exponent of -7. Let's do one more. Let's say I had 0.0003296. Write that in scientific notation. I would simply go 3.296 times 10. How many times do I have to move it? I'm going to go 1, 2, 3, 4 times to get where I want. It's a -4. So it's about multiplying and dividing by 10, but the shortcut is we just use the moving of the decimal to get there. Let's do a couple examples where we go in the opposite direction. Let's say we have 2.83 times 10 to the 5th, and let's do 2.83 times 10 to the -5th. Remember, the negative is a very small number, okay? So here's what I'm going to do. Just as a little thing, I'm going to go, okay, I got 2.83, and I could have a whole bunch of zeros. You know, that hasn't changed my number. That's still 2.83. So the first one I'll do is I'm going to move it for the 5. So I know that sometimes, you know, this is the same thing as saying 2.83 times, and that's 10 times 10 times 10 times 10 times 10. What's that? That's 100,000? Okay, so it's going to be a big number. I'm going to multiply it by 100,000. I'm just going to move it, though. Watch this. I'm going to go 5 places. 1, 2, 3, 4, 5. So my new number will be 283 with 3 zeros. Okay, you notice I put a space there. Just good habits. You know, if I want, I can sort of write my decimal there if I want, okay? If you're doing significant digits or significant figures, be careful. The other one here, okay, let's go for that color. It's a -5, move in the opposite direction. It's going to make a small number. 1, 2, 3, 4. My decimal goes there. So now I have 0 decimal, 4 zeros. I'll just write like this to start. 283. And once again, I can put these extra zeros in here if I need to or I want to, but I really don't need them. I'm going to tidy this up, just make it look a little easier to read. 0, 0, 0, space, 0, 2, 8, space, 3.